Let's talk about another problem. This one is about free fall under gravity. The question says, a person sitting on the top of a tall building is dropping balls at regular intervals of 1 second. Find the position of third, fourth and fifth ball when the sixth ball is being dropped. The question seems fairly straightforward. Let's try to visualize it first. So we have a tall building, on top of that a person is throwing balls. Now when the sixth ball is being dropped, clearly the fifth ball would have travelled for 1 second and the displacement of it is x5. It has moved this much displacement downwards. Similarly, fourth ball has travelled for 2 seconds clearly because 6 comes 2 seconds after 4, and the displacement of fourth ball is x4. And the third ball has travelled for 3 seconds, the displacement of third ball is x3. The sign convention we choose for this problem is downwards positive and upwards negative. Why am I choosing this? Because most of the motion is happening downwards. So it will be easier for me to deal with positive quantities. Now in this you can clearly see the displacements in this case is clearly quadratic in nature because of second law of the second equation of motion, which says s is equal to ut plus half at square. So displacement is a quadratic function of time. So you can see x3 is significantly large compared to x4, which is large compared to x5. It's not a linear increase, it's a quadratic increase. So let's start solving the question. For the third ball, we can say that it was dropped from rest because every ball is dropped from rest. So initial velocity is 0. Acceleration due to gravity is plus 9.8. Why? Because I have taken downward as positive. Now time for which third ball has travelled is clearly 3 seconds. We saw that in the diagram, right? Third ball has travelled for 3 seconds. So t is equal to 3. So if I have to find the displacement of third ball, I'll apply s is equal to ut plus half at square. Now once I do that, initial velocity is 0. Acceleration due to gravity is 9.8. Time taken is 3 seconds. Plug in the values, you obtain the value of S3 or the displacement of third ball as 44.1 meters. So the displacement of third ball or the position of third ball from the top height is 44.1 meters. Now for the fourth ball, we can once again say that the initial velocity is 0, acceleration due to gravity is 9.8 and the time taken for the fourth ball or the time the fourth ball has travelled is 2 seconds only. So if I plug in the values in s is equal to ut plus half at square, the value for the displacement of fourth ball I obtain is 19.6 meters. So fourth ball is 19.6 meters away from the top point. Now for the fifth ball, once again initial velocity is 0, acceleration due to gravity is 9.8, but the time that fifth ball has travelled for is only 1 second. We saw that in the diagram initially. So I'll put the value of u as 0, t as 1, a as 9.8. Once I put these values, I obtain displacement of fifth ball as 4.9 meters. So after this, I am able to find the position of fourth, fifth and third ball when the sixth ball is just being dropped. The concept is very easy. Each of the ball is dropped from rest, so u is 0, acceleration due to gravity is 9.8 and the time taken by each ball can be simply understood or can be simply figured out by looking at the concept in the question. I hope this was very clear to you. Thank you.